David from WatsonX, who will be doing the fourth talk too. So everything should be within 2 hours, yeah. So it shouldn't be way too long. But you're welcome to also ask questions too during the course of the presentation. So let me start now. So yes.
Mary, can you share it on Zoom?
Share on Zoom.
Share the presentation.
Oh, okay. Sorry. Let me do that. Sorry, folks. If you just wait for 1 minute.
Are these going to be made available on Meetup group or anything?
Yes.
It's going live, so
okay.
Yes. Let me see. Where's my? Did I join my Zoom? Where's my Zoom?
Yeah, you can see on Zoom.
You can see me on Zoom, right? Where is my Zoom?
Oh, you don't have to share.
There we go. Yes.
Can you share or not?
Yes. Let me do that. Yeah. You have to do that. Is it good now? Oh, okay, cool. Let me go back to my slides. Wait, where is it? Wait, now I lost it. Okay. Oh, here. Sorry, too many things. Okay, let me see. Can you hear? Okay, let's make sure Ron can capture that. Okay, cool. All right, great. Okay, so we'll start. Again, we have 4 speakers today. It's real exciting. It wasn't planned like that, but it turns out to be, wow, really, 4 speakers in a full room, so we're very excited. Especially after COVID, I think this is like the best I've ever seen, so they're really excited. Thank you for coming. So let me go, wait, okay. This is kind of blocking me, so let me, okay, all right. I don't know how.
No, you're good.
I'm good, okay. Okay, I think your recording is good. Okay, so just a very quick intro too, if you haven't been to AICAMP, who we are, right? So right now too is myself and Ron Majumdar here. My name is Mary Grigleski. So both of us, we are Chicago chapter co-leads in here. We just started helping AICAMP in November, December. So this is exciting. As you know, AICAMP is like global AI developers community with 300,000 and more like AI developers, kind of mostly AI developers and enthusiasts in 150 plus countries all over the world. And AICAMP empowers every developers to learn and practice AI from anywhere at any time. And there are talks that are being recorded, most of them are being recorded and available on the YouTube channel too. There are local community chapters in 50 plus cities and 15 plus countries. So these are like just some of the example. All of the major cities have it. So yeah, so it's pretty exciting. Okay, so how you can get involved too. You can join the community builders team. You can submit topics to speak if you like, and also sponsor the meetups too. In fact, I think Bill, the owner of AICAMP, is always asking us for sponsorship. Who can sponsor? So if your company, if you know that your company can sponsor, would like to send some speakers here, yeah, Bill will be very happy to talk with you too. So you can send your information or copy down this email address, or just go to aicamp.ai to get the contact information and send Bill an email too. Okay, so more learning experiences. AI virtual seminar weekly every Friday. And then there are AI meetup monthly for all the chapters, most of the chapters, I should say. And then there are hands-on AI workshop and boot camp. And then also occasionally there will be AI hackathons. I'm sure maybe some of you are already participating in those. So, okay, and then community shout out. Okay, so here we go. We're giving you time. Like if you are hiring any full-time, part-time, freelance, intern, contract work, please feel free to kind of broadcast your, advertise your openings here. And then if you're looking for jobs and opportunities, you want to share anything, you're welcome to take this time to share with each other, one another. And if you're even looking for projects, collaboration, and co-founders, and hosting events too. And these are the different QR code for joining the Slack or the Discord channel for AICAMP. So, okay, so I'll pause here for a second to ask if anybody would like to share any job openings at your company or anywhere that you are aware of. Anyone? Yeah. No? No? Okay. Actually, last time we had quite a few. Yeah, there are also recruiters here too last time. So yeah, no problem. But if you can think of anything at any time, you're welcome to share. And then if you are looking for jobs and you would like to advertise yourself, likewise, if you want to stand up and introduce yourself, please feel free to do so. Anyone would like to do that? Or if you're looking for opportunities or founders, project founders, collaborators, anybody? No? Okay. Students, yeah, and or you need, mentors or something, yeah, no, yeah, and don't be shy, but we will have more time for networking as well. So yes, yes. Okay, yeah. Where's Nick? Yeah, hold on a second. I have that for Nick. Nick must have Nick must have stepped out for a second. Yeah.
Oh, I gave the other handheld.
Yeah, the handheld. That's what. Oh, I'm using this, but I gave that to Nick. Yeah, so Nick, I don't know, he stepped out. Our helper, Nick.
Okay.
Oh, okay, here comes Nick. Nick, we're gonna need the microphone. Yeah.
Okay, I think one should. Okay. So, my name is Santosh, and I'm a data science graduate student from Illinois Tech, and I have like around 5 years of work experience as a software developer. I'm currently looking out for data scientist or ML engineering roles. I'm a AWS certified machine learning specialist, and I'm very passionate about ML ops and large language models in general.
Okay, cool. Okay, good. Thanks for sharing. Yeah. Feel free to also join our Slack channel, and yeah, there will be folks too responding to you, I'm sure, as opportunities come up too.
Yeah,
So
sure.
yeah.
Thank you so much.
Okay, thank you. Thank you. Yep. Anyone else would like to share about your experience or looking for jobs or something? Yeah. Students? No? Yeah. All right. Yeah, no worries. I'm not going to pressure anybody too. Yeah. So yeah, again, we'll have time to chat too afterwards. So yeah. And so okay, so now it comes to the part of we want to thank our partner and sponsor for today. Thanks to IBM and WatsonX and also the AI Alliance specifically. And then there's also, I think Ron would like to also say a few words about your organization, your team, right? So
Yeah. So Center for CAS stands for Center for Advanced Studies. So we actually work very closely with universities doing research projects and things like that. So if you have any ideas you want to share, or you want to work with professors and students, or you just want to volunteer, these are all open source projects that I do. So it's very easy to get in touch with, just get in touch with me, and then I'll see how we can collaborate. Okay. So that's what Center for Advanced Studies is, and this is where we're streaming this. So this is a YouTube link, simple YouTube at Open Dash Development, and this is where I publish all the projects. So if you're interested, just get in touch with me, or Mary, or Bill, or any one of us, and we'll get started on some interesting projects. So I have things going on with, I'm missing the name here, I guess. But that's okay. That's my telescope project. We're trying to integrate stuff. Someone mentioned Illinois Tech, so we're doing an iPro there. You'll see me on Thursdays. So today is Tuesday, right? So day after tomorrow, I'll be at Illinois Tech. This other one, autonomous racer. We're trying to create algorithms to have a small model racing car. So that's going on at NC State. Students joining on Thursday from Sydney. So anyways, if you're interested, just let me know. And of course, we are interested in doing some events and stuff.
So you have projects looking for students?
Yes, students, volunteers.
Volunteers.
Yes. Yes. So they're all open source. If you want to contribute, or if students want to contribute, or professors want to bring something up which is not in our portfolio, we can also see how that can, right? So, yeah.
all right. Thank you, Ron. Okay, so now just another word is that today we have Faris here from Spring Labs, and then also I'll be speaking too on behalf of Rising Wave Labs too about their stream processor. So just want to thank these companies behind us too. So yeah, and then also too, just some logistics things, as you may be aware, the bathrooms too, that's very important. That's actually, you have to walk through that pathway kind of through to the other side. But the thing is, tricky part is that when you go inside, you cannot come back in to the IBM side. You have to go out through, back to the front door, and that's like a policy in here. So just, I think somebody is, staffing at the door. So you have to go through from the front door. That's one thing. And also, before I forget to, I want to thank our volunteers, Nick, who's there. Nick, and big help, really great, and Mohammed as well. I think Mohammed is here too. Yeah, so these are folks that can be answering your questions if you have any questions. So yeah, so then if you don't have any more questions, then I will have the stage now pass on to our first speaker, Dean Wampler, the head of the AI Alliance of IBM. So, okay, great. Thank you. Yeah, thank you. And let me.
So I go off mute on Zoom, right?
You go mute on Zoom, that's correct. And then you will need this.
I'll need
for
this.
the-
Okay.
And this one is already on. That's what
Got it.
Okay.
Let's get these out of the way. Just hold this. Okay, let me share this screen so it shows up on Zoom, and also I guess I have to plug this in. This is an intelligence test. Can you actually follow this? One more time with feeling, something like that. Okay, let's put this. All right, so are you hearing everything okay? Seeing everything okay?
Not yet. Are you here?
Yeah. Where? Oh, there? Okay. Now where'd the mouse go? Okay. Let me go out of here for a second. We'll try that again. I told you this was an intelligence test, so now hopefully you believe me.
Yes, stop and restart share.
Okay.
And you failed.
It's actually not bad. Dean.
All right, how about now? Seeing the screen? You okay, Ron? Still not coming through.
Because she's still sharing right now.
Oh,
You see on the top
can
it's
you stop that on our stuff? There you go.
Okay,
Got it.
awesome. Good, good. All right. All right, so I'm going to tell you what the AI Alliance is about at the end, because it'll make a little more sense after I go through the slides. What I want to talk about, though, today is what openness means in the context of AI, because there's some nuances relative to open source, although a lot of that still applies, and why it matters, why it's really important, and there are actually some forces that are against openness, but why we think in the Alliance that this is the way to go, and then how we want to achieve it. The QR code will take you directly to these slides. I always put my photography in my slide decks. This is not AI generated. Remember all that fog we had? Well, this is Olive Park in the middle of the fog. It was terrible for mood to have all that fog, no sunshine, but it's great for photography. So we photographers love that sort of thing. Okay, so the agenda then is, what does open mean? And why is it important in the context of AI? And then how do we actually make this happen? And then this is where the AI Alliance comes in. All right, so what does it actually mean when we say open? And you will not hear me say open AI, because that has a very particular meaning. I might say AI in the open or open source AI. I actually avoid saying open source AI because, as we'll see in a minute, it's more than just source code that's important. So for me, that's kind of an odd phrase, even though it's kind of still used conventionally. All right, but let's start by comparing to open source software. And I'm going to walk through this little diagram that's sort of part of the conventional software development lifecycle. You know, we usually start with what I'm calling functional source code. This is what you think of with the stuff in GitHub, the stuff that's going to be a library or a web app or whatever that you're managing in GitHub or whatever. But you're also managing the process code, like your make files, your Docker build scripts, whatever it is, so that you have a repeatable process for not only running your tests, but also building the artifacts like Python packages that you're going to deliver. And these things are managed in Git. Especially GitHub provides a controlled, safe environment. It's hard to hack into. That's important. And you know, what do? You're ready to do a pull request, or you're doing some incremental work. So first you run your tests, hopefully. And this might also include other quality checks like code formatters, vulnerability scans, you know, bad libraries, that kind of stuff. And then you'll do some sort of build. In Python, it's usually just a tar process, essentially. You're archiving, but if it's like Rust or something, you're compiling the code. And that's going to spit out, again, the project owner controls this process. It's not something that a rogue entity has easy access to controlling or manipulating. And it's going to be stored, whatever you create as artifacts, like a Python package will be stored in a secure, trusted repo, so that when you as a library user run pip install or something like that, you're pulling from some place that you think you can trust, as opposed to this website that happens to be in North Korea kind of thing. So you're not doing that and hence pulling down virus-laden software. You hope, and usually works pretty well. Well, it turns out most of AI really falls into this category too. We're still building services, we're still building user experiences, you know, security, vulnerability stuff. It's all still there, but there's some new pieces. And the biggest new piece is these models that everyone is obsessing about. What's different? Well, we still start off with some functional code, although there usually isn't as much when you like tell PyTorch to create a model for you. Your process code is mostly about telling PyTorch what you want to do, or the NVIDIA stack or one of those. But the big new thing is data. And this is why I don't like the term open source anymore, because it's the data that's actually key. You could train a trillion parameter model, but if you don't have any data, it's going to be garbage, right? You'll just start with the random initialization of your parameters, and you won't have anything that works. But it's these massive data sets. And I'm not even showing you all the processes people go through to even collect these data sets. Crawling the web, finding various data sources, deduplicating it, removing hate speech. It's actually a big process. We have a large team at IBM that just does that for a living, basically. Now, you don't really have a test step at this point per se, although if you have functional code, you probably are running tests. But what you're really doing is running a massive training job, which could cost over $60 million if you're training GPT-4 because of the size of the GPU cluster you're running for months. Or it could be something a lot smaller. But what you end up with is some model that you hope is really good, and then you store it in some secure repo. The problem is this model is actually pretty raw in terms of what you want it to do. If you take that model, and in fact, if you read the blog post from OpenAI, what you'll see is they say things like, we spent 3 months training this Sora movie generation model that we just released. Now we're going to spend 6 months doing security scans, red teaming, and all kinds of stuff to make sure that it doesn't output porn or anything that you don't want it to do. So there's this massive process of either tuning, and then I didn't really say it here, but testing, where now you're going to try to align the model with your intention. So I'll use the word alignment a lot, and that is like a generic term for, I want to make sure it doesn't cuss at my customers. I want to make sure it doesn't spit out, propaganda or hate speech or conspiracy theories. When the customer asks for a cake recipe, I don't want a dissertation on the history of cakes. I want a cake recipe. That's actually pretty important. If you read the OpenAI blogs, you'll see where they talk about, not that particular example, but similar examples. And this process of tuning could be as small as running a few more training steps with your own custom data. Like suppose you're United Airlines and you want a chat bot that helps customers with reservations. you might run all of your data, like your historical data about interacting with reservations, so that the chatbot understands in very great detail how a chatbot should work with reservations. But it could also be something extremely sophisticated and time-consuming, like the sort of stuff I mentioned OpenAI does. And there's some buzzwords on here which you cannot read probably because they're too small, like reinforcement learning with human feedback, red teaming I mentioned already. There's a new one called DPO that's an alternative to reinforcement learning with human feedback. This is actually part of the sort of bleeding edge research area. How do we align these models with our intentions? But the point being, you can't really take a raw model that's just come right out of that first training step. You often have to tune it for your purposes and then really do a lot of work to make sure that it's aligned with your intentions. And I'm not even showing all the stuff that we're wrapping around models now, like the RAG pattern, to try to further compensate for the weaknesses of the model in various ways. Now, when you're done with that process, you're going to put it up in another secure repo. It could be the same one, or if I fine-tune Meta's Llama model, I might store it in my own repository, but hopefully it's still safe. And then when people use like the Hugging Face APIs to pull it down and use it, they're reasonably confident that they're not getting malware because it's in a secure place. All right, so the point being, what does all this have to do with openness? Well, we're used to talking about open source software when we're really talking about the stuff that's circled in red, which is all of the source code that's made available so that you can clone a Git repo, you can run the commands on your command line and get exactly the same results as if you pulled that version from PyPy or whatever repo you're using. But in this, I guess I have a few more builds here. What does this say? All right, but, oh yes, human readability is really crucial because if I have source code, I can read it, or a computer can read it, and I can look for things like vulnerabilities, memory allocation errors in C++, all that kind of stuff. And there's this, it has emerged as a real fact that open source software tends to be the most secure software you can get, not because it's hidden, but because so many eyes are looking at it that you tend to find stuff very quickly as a community and fix it. I've been around a little while, as you could probably tell from my blonde hairstyle. And I can tell you there was a time when people thought that open source software was like just the craziest idea. Why would you put that code out there for all those bad hackers to look at and then figure out how to hack? Well, it turned out there were enough people with white hats looking at it to compensate for the black hats. And hence, it actually turned out to be the best way to make secure software. But the stuff that comes out of the right-hand side is not human readable. Usually, it's some sort of binary artifact that's either unreadable or not easy to read. Now, down here in this case with the models, we still have the same sort of artifacts, but really, if we want things to be really open, we should also have the training data that was used. This is a non-trivial thing to ask for because often we're talking about terabytes of data. Who's going to hold that data? Do you really want to pay AWS to download it or whatever you want to do? So oftentimes it turns out that people are not actually open sourcing that code up front, those data sets. They're just opening the models for you to use, but they're giving you a binary artifact, but not the ability to inspect what's upstream. And so what you kind of have to do is first understand what they really mean when they say, here's an open model. Are they actually saying that it's open source all the way upstream? Or are they just saying, well, this is a model that is binary. You don't really know what's in here, but you can use it for anything you want. No commercial limits or whatever. And so since you cannot inspect the model, what you end up having to do then is really test the hell out of it yourself to make sure that it does actually do what you think it should do. And then inevitably, you probably have to do some tuning to just get it aligned to your own business domain problems. So just to summarize this part of things, what's unique about AI versus just conventional software? And really the way to think of it is AI is adding some new things to how we're used to working. We're dealing with binary black box artifacts, things that we really can't inspect the way we could inspect software as source code. And it's really unusual. Actually, did I get that wrong? Oh, they are usually released without. So I did phrase that correctly. Usually, in rare cases where you actually get the code and the data that was used to build them, oftentimes you just get the models. So that means you have to trust the builder's reputation. Like you might believe that Meta is being honest, that if their model isn't full of malware. That's a reasonable assumption. But if it's a North Korean model developer, maybe not, right? You're going to have to verify the model's behavior anyway to make sure it's aligned with your purposes. And you're probably going to have to do some tuning just to make that alignment real in every way that you need it to be real. Chatbots to me are like really pushing the edge of things because they're so, we've already heard stories about people being sold cars for $100 on the General Motors website. Actually, it was Chevrolet, I think. I read one yesterday where Delta Airlines had to sell a ticket at a deep discount to a customer who managed to convince a chatbot to sell him a ticket at a deep discount. So this is really hard sometimes to get this right. And this is more kind of a research area we need to do. There is one other crucial difference for completeness that it should be mentioned, and that is we as developers are used to working with deterministic systems because most of us ignore the fact we're actually working with concurrent systems that aren't really deterministic. But at some level, we can isolate the behavior and say that if I put in inputs X, I know I should always get output Y. And that's great for testing, for automation. But models are inherently probabilistic. The same query input is going to output different results. How do you decide if it's right? How do you decide if version 2 of the model is as good or better than version 1 when you don't have that determinism? So this is kind of unrelated to this question of openness, but it's a real challenge for those of us, again, trying to align models to the behavior we need. All right, so why does all this matter? Well, it's really for the same reasons that open source was such a big win, but with some new considerations we have to factor in. One is that we'd really like to have open models as well as data, but also the source code. And the reason it's nice to have even just the models and data in the open, if not also that source code and the training data sets, is that it stimulates innovation, both in the research level, where people are constantly improving the architectures of networks, the methods they use for alignment. I said that's a hard problem. There's still a lot of work there. And also optimizations. Almost every big organization that's doing research on AI has a lot of people working on how do we make this as fast and as efficient as possible, even when we're just doing inference, which is the serving of the finished model, and maybe also doing training optimizations. It stimulates commercial innovations. People come up, I'm kind of amazed some of the ideas that people have come up with. My favorite one right now? There's a bunch of services now that will record your meetings, capture all the action items that they detect, say who said what and all this. You don't even have to take meeting notes anymore. You can use these services to just do all that for you. I think that is such a brilliant use of AI and fairly easy to get right. It's not nearly as hard as a chatbot. And we all know that our productivity is going to be accelerated by AI. So all of this would not happen if we were all stuck with just proprietary offerings for AI. We would not have this ability. The last one is important for a lot of enterprises who don't want to use web services. They really want to host everything themselves, whether it's in a VPC environment in a cloud or actually in a real data center that they own. And I think also there's a lot that you want to do with tuning that's just cheaper to do if you can do it on site with your resources that you control. Sorry for all the bullet points. I really couldn't think of a better way to just say all this quickly without using a lot of bullet points. The other important thing we learned last year, this is kind of sort of a research direction that has really proven fruitful, is that we can make some really interesting trade-offs on the size of models versus the kind of performance we need. So an advantage of the really big models like the GPT-4s and so forth is that they are extremely generalizable. You can ask them almost anything, and unless they have safeguards in place that, well, we're really not going to tell you how to build a nuclear bomb, that kind of stuff. They can just pontificate on anything. They also tend to have very high scores on benchmark tests, but they have extremely high operating costs, even for inference. I think to run GPT-4, I read somewhere that the estimate is, and we don't really know how big that model is, but the estimate is that it takes like 8 H100 GPUs from NVIDIA. Those things are, I think, like $100,000 a piece, and of course they burn through power like crazy. So it's a really expensive process to even just do inference with big models. whereas small models actually have some interesting benefits. Now, they are less generalizable, but in a lot of cases, you can tune them to be good enough for your specific application, like helping customers with their reservations or helping people write code. They don't need to be nearly as big. In fact, they can be like 100 times smaller than some of those big models and still work really well, and as a result, they're much cheaper to run. Okay, I mentioned for open source software, one of the things we learned a long time ago is that nothing is, how's that phrase go? Sunlight is the best disinfectant. So when you have code that you can inspect, then you can really verify what it's doing. This is really important, but it's really hard in the large language model case. And we also have some new attack vectors, like prompt hacking to get around guardrails that people put in place. We do like the fact that when we have open source software, we have the code, we can scan it, and also even if we have the data sets, we can scan these things and look for bad content, look for vulnerabilities and so forth. But if I just have a binary model, it's not nearly as easy to do this. I have to rely on the reputation of the builder, as I said earlier, and I then have to do a lot of red teaming myself, which is, if you don't know what red teaming is, it's basically you being aggressive about trying to hack this model and to figure out ways that it might be vulnerable. All right, so as much openness as we can get lets us do this kind of security inspection, security hacking to improve it. The less openness we have, the harder it is to do these things and validate that we're getting what we need out of these models. So how are we going to actually achieve this in the open when we're competing against companies like OpenAI that was just valued at $80 billion yesterday, if you happen to see that headline? Even IBM doesn't have $80 billion lying around. I don't know why we don't. I mean, we're big enough, shouldn't we? But anyway. All right. Well, there's a lot of things we can do. Like, everybody in this room needs to learn how to use AI. You may not know how to train models. You may not understand the optimizations that are going on at inference. But you really do need to understand how to use this stuff and how to be safe using it. Again, because I'm an old guy, I remember when the internet was new. It's kind of hard to believe now that there was a time before the internet, but it did actually occur. And it's basically, if you've ever seen the Flintstones cartoons, that's kind of what it was like before the internet. But you just kind of had to learn how to be safe in something that was totally new to you, and we've got the same problem here. How are we going to learn how to use this stuff well and figure out how to work around the limitations we have? Can we pool our resources together to do things like build as many broadly applicable models and tools as possible? OpenAI is fantastic for a lot of generative uses, but IBM actually works on models for like generating chemicals. In fact, I think we're not the only people who do this, but like Meta has a big team that works on like generating novel chemistry. Can we create standards that help us actually find the right ways to plug in modularity where we need it? Did I hit the right button? I hit the wrong button. Sorry. Let me quickly go back. I'm nearly at the end here. And we also need to work together to fund research. So I've talked to a lot of like the world's best researchers in this field, and that the number one complaint they have is we just do not have the money to buy the GPUs that the OpenAIs and the Microsofts have. So we're actually left on the margins. We cannot do the research to find the next generation of stuff because we don't have the resources. And also, here's a key thing where there's a lot of discussion now at the policy level, like testimony to Congress, to the European Union, about what is appropriate for safeguards. Do we really need to lock everything down because AI is fundamentally new and different? Or is it actually better to think of it as just the next generation of open source, and we should apply all of what we know about how open source has succeeded, but attack the new problems that I mentioned previously? And of course, we believe that's what you should do, and that's why this alliance was formed. Unfortunately, the URL is cut off a little bit. If you just go to thealliance.ai, you'll come to our webpage. This is an international consortium. It started with 50 members, universities, startups, and other research institutions. We just announced another 30 a couple of weeks ago. We're a little light in Africa and South America, but we're working on that. And the numbers on the right are just they're not really all the people and resources committed to AI, but there's just a lot of people and money behind these organizations. You know, it's funny, I just noticed this. I mentioned earlier that OpenAI was recently evaluated at $80 billion. Well, it turns out that's about the R&D funding for all of these organizations is about the same. So maybe we can compete. So, you know those things I just said a minute ago that we would like to be able to do to make AI successful? Well, we've defined 6 focus areas that we're organizing people around. One is really skills building and education, as well as fundamental research. The one that I'm actually most involved in at the moment is trust and safety. I'm working with a team at Meta and other partners to really define the state of the art for benchmarks, for safety tests, you know, across the spectrum of everything we might need to do. We today just launched this group that's working on building models, tools for building models and applications, like your Lang chains, llama indexes, and stuff. Not everybody wants to keep paying NVIDIA, you know, extremely high markups for their GPUs, especially when you have to wait a year to even get them. So we're working on hardware portability, so you can use AMD or Intel or other accelerators. We really do want to have as many models and data sets out in the open as possible across the spectrum of use cases like science as well as generative text. And then finally, we want to lobby for and define policy around openness as the right way to solve problems and not treat AI as something fundamentally new that has to be locked down. Okay, so to wrap up then, so the Alliance was founded on this premise that successful open source software really still, those lessons still apply to AI. We just have to account for what's new and different and make sure that we really maximize the availability of AI, the benefits of it for people while, you know, managing the safety concerns. So once again, the same QR code if you want the slides. Do visit the alliance.ai. You can sign up for our mailing list. And you can spam me at these addresses. So anyway, thank you. Do you want to take questions or just wait till at the end? Is it okay? Okay, couple questions? 5 minutes or so? Did you have one?
Yeah. You mentioned
There's a guy coming with a mic. Why don't you give him a chance to get over there?
you mentioned like open model, right? But then we saw like we have a closed loop. We cannot expose everything.
Right.
And then we also talked about innovation and maybe kind of architectural innovation there. But then I think, is it possible to change even the architecture when you are exposing those models? No, right? I mean, there's no scope of changing it.
So that is a problem. So suppose that you like Meta's llama model performance, their model called Llama.
Yeah.
But it's closed in the sense that you don't have access to the data. Now, people do tend to publish these so-called data and model cards that explain a lot of details, but it's still not the same thing as checking out a repo and clicking run.
Correct, yeah.
So the good news is most people only need to take the models like that already have good performance in general and then tune them without actually knowing what's inside them. And there are various techniques for making that just work. You can actually inspect the architecture of a model. You just can't really understand what all the parameters mean.
Correct, yeah.
So you can actually get a lot done even with that black box. But if you are a researcher and you want to see, all right, Llama's based on transformers, which is a buzzword. How would they change that? What should I do to make that even better? Then you're kind of stuck. Now, there are some great examples of models that have deliberately been made completely open source for research purposes. The Allen AI Institute open source one called OLLAMA, and I think it is spelled O-L-L-A-M-A. It's a really good example of a research approach that produced a really good model, but you can see everything you want to see about it, all the way back to that source code and data sets. So that's, if I were a researcher, I'd be looking hard at that. But if I'm just a user of AI, I would start with something like Llama or one of the others, and then just tune it for my particular needs and not worry about the fact it's black box.
Got it. Thank you.
One here? You want to hand him the mic? Yeah, there you go.
I was literally at a presentation by Databricks at lunch, and I'd like you to react to a comment he made that he said, yeah, the large models were generalizable, but he said a small model and you spend the money on fixing the data, cleaning the data, can actually do better than that larger model. Do you have?
Yeah, I believe they're talking about this is an experiment they actually did at Databricks, I believe. I forget the name of that model, maybe Mosaic or something, where they very, very carefully picked the data set they did the training on, so it was extremely high quality as opposed to, well, the internet.
Yeah, they did high. They said they did higher quality and then medium quality.
Yeah.
But I haven't found the details. I just heard this.
That is actually another interesting. I've seen several examples lately where people have been really cautious about the data sets, really pruned it down to the highest quality for their purpose, and it does actually produce very good results. You get a lot of bang for your buck in terms of model size. And that's really what you want to do in tuning anyway, even if you start with a general purpose model. So yeah, I don't think that was BS.
Okay.
By the way, a little story about Databricks. So the two co-founders, two of them, were Jan Stoica, who's a Romanian professor of CS at Berkeley, and his grad student, Matei Zaharia. Matei's now like 37, Jan is like 50. According to something I read recently, they're both worth about $1.6 billion now in Databricks stock, and they're like the third and fourth richest Romanians in the world. So just a little factoid that you didn't really need to know, but I think it's kind of amusing.
Thank you.
Maybe we should move to the next speaker, and I'll be around afterwards, happy to talk to people. Okay. Get all decoupled here.
Yeah, is there an adapter?
Thank you. Thank you. There we go. Okay. Can everyone hear me okay? Awesome. So good afternoon. Oh, yeah. Oh. Oh, sorry about that. Good, do you see it? Awesome. All right, good afternoon, everyone. My name is Faris Habib, and I'm a senior software engineer at Spring Labs. Just a little bit about Spring Labs. We're a fintech startup dedicated to advancing data privacy through some cutting-edge technology. And this talk is going to be a little bit on the higher conceptual level. It's not going to be too technical, but it's all about sharing my insights into training an open source model for NER in PII detection. So a little bit of an overview on NER and PII recognition. NER, named entity recognition. We wanted to do a project on this just to extract meaningful entities like names, location, SSN, date of birth, as it relates to PII, personally identifiable information. And so our focus of the project was detecting PII to prevent data breaches and enhance privacy. And there's a little bit of some intricacies that we noticed and solved with an open source model like BERT. So we turned to BERT because it uses the transformers architecture, which is known for its deep understanding of language context and natural language processing. It's an open source model developed by Google, but there's also some other flavors of BERT that we were looking at as well, like DistillBERT, which is a little bit smaller and lighter, that Hugging Face developed, as well as Roberta, developed by Meta, which kind of tweaks the
the benchmarking criteria. We decided on BERT just because the natural language processing it contains was good enough for our task. The bidirectional training it offers in understanding different words and texts from right to left was extremely useful because in our training set, we wanted to be sure that we were identifying PII that was detectable if it was similar to other PIIs. So let's say you have a name like John and then a address street name like St. John Street or something like that. We wanted to be sure we were introducing a lot of context to the training set such that the model could actually identify that nuance. So just a little bit about our project motivation and goals. Like I said, the primary motivation stemmed from the need for to detect highly PII within a vast and varied set, a varied collection of data sets. So in terms of data preparation and annotation, that was actually probably one of the most tricky parts. We collected a lot of data sets that were open source. You can find actually a lot of PII data sets that are open source on Hugging Face. So we collected a lot of those as well as generated synthetic data as well to basically produce the results we want to have the model understand the nuance of different words to detect PII. We generated about anywhere from 500,000 to 1 million records in combination with the open source data. In terms of the model training process, we made use of PyTorch as well as the transformers library from Hugging Face. It just made it very simple to integrate with an open source model like BERT. Also adding custom training epochs alongside initial pre-training. Model training was very iterative. When you have an open source model, you're essentially fine-tuning it to the desired results you want. So what I did was I adjusted a lot of hyperparameters to evaluate the model performance. And in terms of evaluation, the main focus was looking at precision, recall, and accuracy. But I also generated a confusion matrix to understand the model's strengths and weaknesses, and added some data augmentation to the training set as well to make sure it has enough variability in the training set. So in terms of the evaluation and results, post-training it achieved successful metrics, which I was a little skeptical about. That likely tells me that the model was being overfit. And for those of you who are not aware, overfitting occurs when the model performs exceptionally well on training data, but very poorly on unseen data. So that to me indicates that the model has memorized training data rather than learning generalizable patterns. So in order to mitigate that, some strategies I implemented was introducing more varied data, so a lot more context into the data sets with a lot more like different kinds of sentences of like, hi, my name is John, I live at John Street, XYZ. And then basically varying that context with different greetings, different goodbye scenarios and stuff like that. But I also introduced regularization techniques and dropout layers to ensure that there was even more variability. It was also necessary to implement things like cross-validation and regular testing on a separate validation data set to monitor the model's performance. Overall, it is good, and I'm happy about where it landed, but it took a really long time to iterate that process to ensure it wasn't being overfit. So in terms of lessons learned and best practices, it's extremely important to have continuous high-quality data annotation and the need for regular updates with training that data. It was pretty simple to do so because what I did was set up the process through a service called RunPod. With RunPod, you can actually set up in you can configure as many GPUs and CPUs as you want. So they let you borrow, a couple H100s if you want to do your training process. So from there, they make it very easy to say run a training in anywhere from 2 to 6 hours. But it's extremely important that you're always training the data. The project also taught us about invaluable lessons like data quality and the power of fine-tuning, as well as best practices for evaluating the model on the specific PII metrics that we were looking at. In terms of next steps, what we'll likely do is evaluate a different model from BERT. BERT was a good generalized model, but we're really looking at a model that can be integrated on the client side of an application. So if it's integrated on the client side of an application, it needs to be able to run efficiently, like likely less than a second, which means we're going to be likely utilizing CPU resources, not GPU resources. A lot of the transformers architectures, you get a lot of good benefits of the deep learning architecture because it's utilizing a lot of GPU resources. So we're likely going to be taking a look at something like Spacey v3, which introduced transformers architecture into their pipeline, so that we can get an efficient model. But there's also optimization techniques you can introduce that ONNX runtime introduces if you're ever loading a model on the client side. So we're also taking a look at that as well. But best practices, make sure you're regularly updating the model with some new data, and make sure you're implementing robust data privacy measures during all stages of training as well. So a little bit of shorter talk. That was basically all I had. But on the right-hand side, you'll find all of our products, including AI Guard, which uses the model I trained. And I definitely invite you to connect with me as well on LinkedIn too. So thank you. And I should say, were there any questions?
Yeah, can you explain more about your data set? I have a question regarding your data set, like what's the data set was?
What was the data set?
Yeah.
So the data set was a PII data set that we collected from Hugging Face. So Hugging Face has a lot of open source data sets that you can use for training. As well as that, we generated synthetic examples. So we basically generated a bunch of sentences and scenarios where we create a bunch of free form text, like, hi, my name is this. Think of like an email or like a greeting or a message card or something like that. That's what we really wanted to do, was to be able to identify PII in free form text. So we generated a lot of data sets in the range of hundreds of thousands upwards to 1 million, and then annotated that data set with the PII entities we were looking at, like person, location, first name, and so on.
And did you use any pre-trained model for this, NER model?
It was the BERT model that we
BERT
used
model.
for it. Wait for the microphone to go. Yeah, it's all good.
It's all right.
Yeah.
Did you? Hey, good looking. Can you hear me? Oh, okay. Did you do any work in entity linking? For instance, this is John and my social security number is X, and kind of doing the entity linking?
Yes. In different in the data set we were training with, yes, we did that. It was so it was important to vary that, right? So like with some sentences in free form text, we introduced like anywhere from 1 to 5 PII, whereas others it was just like, 1 or 2 or something like that. So yeah. But I made sure to vary that such that the model had a good job detecting not only PII, but it had a good job. It would be good at not being able to not having false negatives essentially for PII detection.
Okay, cool. And then just one more follow-up on the gentleman's question. So you train this both on unstructured and structured, or just unstructured?
Unstructured data.
Okay.
Yeah.
Awesome. Okay.
Yeah.
Are there any benchmarks for PII data that you can compare your model to against other models?
I invite you to look at Presidio's repo. Presidio is an open source repo from Microsoft. They have a lot of benchmarks they use. They actually use a model, they use the Spacey model for their evaluation. But it's really good at NER training for token classification. But yeah, their evaluation metrics are definitely like the standard to compare against so far that we found. So yeah, we compared it with Presidio.
How'd you do?
Really well. But again, the problem of overfitting is a very common problem. It still does poorly on like brand new text that we've never seen before or never trained on. So the tricky part is always making sure to update the model to understand new sentence structures.
The problem of overfitting, as you said, how do you make sure that even when you're trying to add outliers to the data, how do you ensure that the data can be tuned later onwards without having any kind of discrepancies?
How do I ensure the data can be tuned later without any discrepancies? In terms of adding additional examples, or?
In terms of it just being accurate in identifying PIIs and NERs.
I mean, and you can tell me if I'm answering your question correctly, but like the problem with models is that they will degrade over time. So it's a continuous process of always training the model to make sure it continues to stay accurate, and introducing new and regular and standard data to the model so it doesn't degrade over time. Does that kind of answer your question?
Yeah, but doesn't that make the whole process even more difficult?
Absolutely, yeah. But the goal of this project was to have high confidence in PII detection. How many more questions do you want me to take? Okay, yeah. Yeah. Sounds good.
Thanks for the talk. I like it very much. I'm just curious. I use BERT for natural language processing, not much for. This is a little bit like NER, computer vision, object detection. I'm just curious. Compare with like Gaussian or some like or some other computer vision like object detection.
Sorry, I don't mean to interrupt you. Could you speak up a little bit?
Oh, I need to. Okay.
Thank you.
I'm just curious. I think I'm fine. Compare with other computer vision techniques for this kind of object detection, like a Gaussian or faster Gaussian, those kind of stuff for object detection. What's the benefit of BERT? Because BERT, I use that a lot for chatbot development because I need a lot of natural language processing stuff. But I haven't tried this. And my second question is, when we go production with a real messy corporate data, what's the expected bottleneck you can handle with this kind of platform? Thank you.
So the first question, I'm not entirely sure how well BERT will do with chat features. I was specifically looking at it with NER and token classification. It is an open source model, and it is transformers models are generalized, right? They're trained on a large corpus of data, and they're generalized to be useful in many different classification trainings. So you could probably train it to be a good chat-like interface, but I'm not too sure how well it would do compared to other models. In terms of the production question, that's a great question. It all depends on the data you're training with, to be honest. It's really so when we were evaluating it, what we did was some of the issues we ran into is that transformers models are very slow on the client side. They took about anywhere from 2 to 4 seconds, and there are different ways we got around that bottleneck. You can quantize the model, of course, but then that gets rid of some of the precision and accuracy. It actually made it a lot worse. So what we decided to do was do some half precision. So we basically halved the model size, and that had evaluation metrics that were comparable to the full model size. So that reduces the speed significantly, but that's also why we're looking at other models like Spacey that can actually, it's a little bit faster and a little bit more efficient to use on the client side. Yeah.
Thank you. Is it on? Nope, I don't think this. I can try this one. Okay, it sounds like this is working. Well, thanks for a great presentation. So 2 questions, one related to the other. First of all, how do you handle, what is the metric for evaluating the quality of the model? In other words, hi, I'm John, my social security number is 1, 2, 3, 4, 5, 6, 7, 8, 9. Hi versus hi, I'm John, I live on, I'm 45 years old, I live on 123 Main Street and all that. And so related to that, how do you define the cost of a false positive relative to the cost of a false negative?
Yep.
Thank you.
That's a great question. So that goes back to the evaluation metrics. So we were really looking at accuracy, precision, recall, F1 score, F2 score, as well as the confusion matrix. What we really wanted to prioritize was accuracy and recall, right? So we were okay with a few false positives, but the goal was, of course, high confidence. So whenever we did see low scores on, say, false positives or false negatives, that told us that we needed to add more data into the training set with more nuance with examples like that. So yeah, literally it's looking at the sentence structures and kind of varying the greeting a little bit, varying the goodbye scenario, varying the sentences that were used. And then we just threw in, so the data augmentation process was really just throwing in a lot of random text into that as well, because we wanted to be sure it could detect those PII entities from random garbage text. So it's more training and constantly evaluating it with precision, accuracy, recall score. And if it drops below a certain metric, like 96% or something like that, that tells us, okay, we need to keep training, we need to up the training sets and perhaps look at other optimization techniques too.
Yeah, so you answered a slightly different question.
Oh, sorry about that.
The question is, if I give away my social security number, the cost
Yeah.
of that is higher than me giving away
Yes.
my phone number, my address, my age.
Yes,
How
yeah.
do you, but on the other hand, I just gave you 3 pieces of information which are worth less than one
Yeah.
high value. So how do you handle that?
So for our model, we were only looking at 6 or 7 specific entities. SSN was one of them, person, location were some others, and then a couple more entities. For the main focus of this training, we were only focused on those entities. And then it's an iterative process. On the next training set, we will introduce those entities along with the ones we're already training with and ensure that those entities also receive a high evaluation metric. Yeah. Oh, yeah, go ahead, sorry.
On the client side, what is your security mechanisms that you'll be using for the data? For example, encryption or the security?
So we have a product called TrueZero. TrueZero is a tokenization product. So essentially what we'll do is we'll encrypt the data as it's being exchanged in real time on the client side. And then through different access controls, we will be able to decrypt the data depending on who needs to look at the data and who doesn't. So it's a tokenization technique. Yeah, I do see your hand over there.
What was the fine-tuning technique used to train the BERT model?
Cross-validation. So I made sure to have I introduced a k-fold of 3 and a batch size of 32 to ensure that it would be able to run through, it split the data up into training and validation sets, and to be sure it was able to run through all the examples with the data augmentation with the PII entities that we were interested in.
No, I'm asking about the fine-tuning techniques like the PEFT methods. Any of the PEFT methods that you use to fine-tune the model, like the LoRa or...
I never introduced any of those techniques just yet, just cross-validation, hyperparameter tuning, and then making sure I have a constant batch rate. That's it.
Oh, okay, okay, got it.
How many more questions do you want me to? Cool, sounds good.
When you were talking about the variation, do you foresee using other language models to add that kind of variation, and how would you incorporate that?
Like non-transformer models, or?
Potentially, when you're talking about the issue of, hi, my name is John, you wanted to add new ways of saying the same thing without necessarily giving it. Like using another language model to generate the additional variation.
Oh, that's interesting. I haven't thought of that. I mean, there's a lot of tools, especially in Python, that can generate synthetic data, as well as the open source data that was on Hugging Face. That was enough for us. You could certainly go down that route, but I don't see the need to do that when the tools that exist today are good enough for now.
Gotcha. I know some models like GPT, they have restrictions on using it to train other models, so.
Yes, they certainly do, yeah. But yeah, I mean, you can even look in Microsoft Presidio. They have a lot of evaluators, and actually they use Faker for their data generation. So that's essentially the same approach that we took with it for training our model.
Thank you.
Yeah, in the back.
So what sort of false positive rate did you see in practice, and how are you dealing with out of vocabulary issues?
Out of vocabulary issues like?
Say, for example, someone has a very unique name that doesn't appear in your training data set.
Yes, like my name, Fars. So if the latter, all we did was just make sure we introduced those variabilities into the training sets. And sorry, what was the former?
The false positive rate, or maybe like a confusion matrix, or can we?
What was the?
How many like false positives were you seeing in practice?
Not too many. So the first training, so sorry, not the first training, but I think like the third or fourth training that we did with 500,000 data sets. In terms of false positives for each entity, it was anywhere from about 1 to 5. So when you see those false positives, it's just introducing, it's making sure you're tweaking the data set such that it can recognize those, it can better interpret those false positives.
Okay. And in practice, if you're implementing this at, say, a client, or on a client's data sources, would you need like a second level of review for the results from your model, or would you be confident just saying that the results from your model are good?
So the way we use our model is it's in combination with our tokenization product, and that runs through, so we run through a lot of testing end-to-end to ensure that the model is properly tokenizing the right kind of PII detection. Yes, you could definitely implement something like that, but the evaluation metrics we look at, as well as our additional testing, tells us like, okay, we have high confidence that can actually detect PII.
Excellent. And last question, what sort of PII in particular were you looking for? I know you mentioned names.
Yep. So yeah, names, location, SSN, DOB, bank account number, credit card, and then we were testing with other rare types of PII that you may not necessarily see in a lot of examples, like driver's license or like specialized unique identifiers for like states and stuff like that.
All right, thank you.
Cool, great questions. Thanks, guys. Oh, thank you. Yeah, I think so. Oh, that's a good idea. Anurag, the new guy we hired that I told you about? Yeah, 2 weeks ago. Oh, sorry.
This is what that, and then to share. Here? Oh. Where did it go? Oh, here we go. Okay. Okay. So I'm gonna go now because we still have David too. So I'll keep mine also a little short. I know in the description I says I will be coding up, but actually instead of that I will be kind of talking about more high level, kind of conceptual level. And just so you know, too, my title here is about building a RAG data pipeline, and then specifically too with rising wave stream processor. So actually, let me first ask folks too, how many of you actually, you are more data engineer, like you're doing more software engineer for AI. Yeah. So a few of you. Yeah. Okay. So maybe a bit more relevant for those of you with that, because or how many of you are actually more pure data scientists too? Yeah. So quite a few. So I know too there are differences. If you're an engineer, you're dealing more with the software, or if you're a data scientist or computer vision, you're actually the subject matter. But anyway, this one is more about building RAG data pipeline, and specifically again with rising wave stream processor. So let me real quickly too. Again, I'll go a little fast too in here, just more introductory, just because most of you maybe are not as interested, I'm assuming, right, in this kind of aspect of AI. So okay, so this is just a quick run through of what I'm going to talk about, introduction, and then also I'll skip to some of the introduction to ChatGPT and GenAI, but also wanted to talk specifically too about data pipeline. How does it fit into this picture, and what kinds of tooling are needed, right? And what is rising wave specifically, and also what is vector database on high level, and then building a RAG data pipeline using these tooling too. And essentially architectural, conceptual walkthrough and some resources. So real quickly, I'm, yes. Oh, it's not changing? Okay, okay, sorry. Yeah. Let me stop and then share again. I thought I already shared. This one? Okay. Let me make sure. Are you seeing it share? Huh. How come?
On one of your other screens, it said resume share.
Oh, okay. Maybe I think maybe I was sharing two things. I'm sorry. Just am I sharing two things or no? Right. Sorry.
Which one do you want? The robot one?
The robot. Yeah, the robot one. Yeah. Okay. Let me then go back to the robot. This one? Are you seeing it sharing now?
Yeah, I did the robot.
Sorry. Yeah. Is it? I am noticing it is not progressing. I'm not sure. I am sharing that, right?
Yes, I think there's presentations up there.
Right.
You're sharing
one that says resume share.
Oh, that's what you were saying.
Right.
Okay. This one maybe? This one? Actually, I'm not already.
So start again like you did before.
Okay.
And then it'll come back on.
It was on your email.
In my email. Oh, sorry.
On the screen that shows your email.
This is my email. Oh, this one?
No.
Let me see. Sorry,
Start
it's too
like
many
you
things.
did again.
Sound like a. So sorry. I have too many things. It is true. This one is what I'm sharing. So maybe let me kind of not share.
If you're presenting that, just share that one thing.
Okay, so well, first of all, slideshow, and then I'll share this, right? Okay. Go back to my Zoom. Sorry. Sorry, cannot find it. Here, okay. Share this rising wave.
Okay, stop. You see where it says resume share?
Oh, okay. Yeah, so stop share. That was it. That was for that one. All right, let me leave and then come back again just to see if that might. But then I need that link again, so I have to go to this guy. Open. So sorry. All right, I don't join this, and I'm going to continue. Share. Now I cannot find my site here.
Stop. All right. Do you see where in the green where it says resume share? Can you every time you attempt to kill it, right? That's probably your issue.
Oh.
Kill that window.
Kill this window.
Yeah. Kill that.
Not
that's
like
what-
stop. Well, that would be. I'm so sorry. Okay. If I okay, let me do that. Do it again. Share. Resume share.
And it's not working. So if you can kill that entirely, yeah, leave meeting.
Oh, but it would just be stop share.
Will that work?
Okay, so now stop share is here. So
can you share now?
let me do it again. Yeah.
Restrict you from sharing.
This one. This one. Share. And that's what I do.
See that resume share still up there. It looks like that's a dead process if you kill it. You hear what I'm saying?
Yeah, I know what you mean.
Right,
Yeah.
right. See if she can get rid of it.
Leave meeting.
Right, leave meeting.
Leave
Go
meeting.
ahead, leave meeting, and then just come back in.
Ah, okay. Launch meeting. I'm so sorry.
I'm audience tech support.
Thank you. Okay, continue. Okay, let me do it again. Share, and then I'll actually share that. Oh. But then we see.
Still there, I know. So go control alt delete and then kill that process.
So sorry. That's what I killed already. I quit Zoom. Okay. Oh, you mean the Zoom? No, I think it's already killed.
Yeah, so Mary, that doesn't matter. I'll capture it from the.
Okay, from the camera. Okay, all right. I'm so sorry. I don't. Okay, sorry. Yeah, okay. Okay, so wait. Where's my Zoom? Okay, it's starting. Sorry about that. Okay. All right. So
One last time.
join. Okay, I won't join with that. Continue. Okay. Share screen. Now I will share this, which is here. Okay. Are you okay? Yeah, sorry. Here. Okay. So. Okay. Okay. Oh, this good now. Okay, all right. Okay, all right. Okay. So sorry, everybody. Yeah. Thank you. Thanks for your help. Thank you, everybody's patience. Okay. All right. So this, which means I have to go even super fast. Thank you. Sorry, and thank you for your patience with me. Thanks for your help. Okay, so I'll just skip straight to Rising Wave, and as such too, I was going to introduce myself, but it's just real quickly, I'm a developer advocate. I just left actually DataStax. I was working with more, actually I worked with their streaming product, Apache Pulsar, and then got into GenAI. That's how I got in. And then advocating for their vector database, which is Astra database, but now I don't work there anymore. So I'm actually more like independent. So here I'm helping Rising Wave. So they are about stream processor. How many of you, just kind of out of curiosity, have maybe perhaps already working with Rising Wave by any chance? Okay, no worries, it's a stream processor. How many of you have heard of it, maybe? Maybe, yeah, a few, yeah. So they are kind of small company too, I have to say, it's based in California, but they are stream processor specifically, and they are SQL based. They also kind of have their database capability. It's essentially natively they're using Postgres. So just to give you an idea. So it is a stream processor, but let me really quickly then give you an introduction to stream processing in case it is new for you. So stream processing is a data processing approach that deals with like continuously flowing or streaming data. And then essentially too, what is special about it is because it's streaming, that means you can perform real-time analysis and also direct like transformation of the data as it comes in and compute the data, do all of these things too, which is kind of different than traditional like batch processing essentially. So as you can see, the diagram is input data comes in, your stream processor, stream processing engine process it at the same time as it comes in. So just think of you're watching game and the statistics can kind of be analyzed right away for you. So that's the kind of thing about it too. And then essentially too, the goal of it is to extract like valuable insights, detect anomalies and trigger actions based on incoming data. So it's a very reactive type of purposes to it too. And then just kind of mention too a little bit right there, stream processors basically support like queries as well. So for example, like filtering, you can have data that comes in and then you can select specific data from a stream based on predefined kind of condition too. Example is like filtering out log entries that contain errors or for immediate action, that type of stuff. And also for aggregation too. So over a certain period of time, you may want to say, well, I want to do a count of certain fields, of containing data greater than 10, for example, something like that, right? Aggregation kind of purposes too. And then also joining streams. You can have multiple streams, and then you can do different joins in order to search for the answer that you look, kind of more complex type of query analysis. So essentially, that's what it is. And then just in continuing, there's also what is called windowing, is that it allows you to group data into some kind of fixed time interval too. And so then in that case, you can kind of window off certain periods of time of these data as is applicable for what you're looking for. And also like pattern recognition too. So basically looking at patterns or sequences of data, events in the data stream too. So example here is like detecting a series of login failures as a security breach attempt. Yeah, so it's a kind of multi-purpose kind of use too. And also, as such too, it's like if you do monitoring type of thing, is the kind of stateful processing. So it maintain like state information to analyze data over time, such as like tracking user sessions, that type of stuff too. So it's kind of multi-purpose and very useful, especially in kind of data center type of application too. So now what is Rising Wave, right? It is an open source distributed SQL-based database for stream processing. As such, I mentioned that they use Postgres too. So kind of very open source in nature too. And it's designed to reduce complexity and cost of building real-time applications. And it consumes too the streaming data and performs like incremental computations. When new data comes in and updates data, dynamically, very dynamic in nature. You don't batch it. You don't wait until the input stops and then you process. It's more like as it comes, you kind of look at it too. And then also as such, as it comes in, then it can also kind of build things, maintain the results, in its own storage as well, and then sends it to downstream as well. So very dynamic. And as such, Rising Wave is built in Rust. And it's SQL-based Postgres compatible. And the storage and the computations are separate. And then the good thing about it is that if you need to scale, especially operating in a cloud kind of serverless environment, it's actually very, very good because you can be scaling, storage and doing computations separately. They don't mingle. So that's kind of thing about it. And also, that's right. And they also have what is called like materialized views too. If you're familiar with SQL, you can build these materialized views for specific kind of processing, kind of windowing all your data off too. Okay, so this is just a diagram to kind of show you too. If you're familiar with stream processing, usually it comes in, there are some events that would trigger events happen, then you need to trigger certain actions. And the source can be, it works with connector, with Kafka, Pulsar, Amazon, Kinesis, all of these too, as you can see. And then Rising Wave, which comes in, it also has its own real-time ingestion. And then it does all of the stream joining, as I mentioned earlier, filtering, windowing, aggregation, all of these things. And then essentially too, as data comes in, it can continuously update, and do all the querying data as well. And over here too, as you can see, the idea of doing data pipeline is that you have a source and then it comes in, does all the processing, and then you send data downstream to another destination. So over here on the right side, as you can see, is called sinks, and you can actually essentially transform the data, then sends it over to a database or data warehouse, and in fact, they work well with snowflakes as well, if you're familiar with data warehouse, data lakes, and message queues as well. So that's kind of in a kind of nutshell. And then also want to show you about stream processor. Why do you want Rising Wave? Is that, the top one is showing without Rising Wave. As you can see, you can have multi-stream of data coming in. And then essentially too, you have different like state processor, all of these things, and then you can have different Kafka. As you may be aware, Kafka is a message broker. You can have different Kafka to be collecting all of these data. And then you have to, again, filter the data and send it to another topic of Kafka, and then you send it to the database. However, with Rising Wave is that you basically can eliminate that extra step in between the message broker. It goes kind of straight to, the one single Rising Wave instance can kind of handle all of the stuff that, as you can see up there, for multi-stream type of processing. So that's the advantage of it too. Plus, if you are like SQL Server, it's actually more familiar with you as well. Okay, so this is the Rising Wave architecture. It includes these key components too. It has what is called serving layer that basically takes all the queries, all of these things, the front end kind of node, and do all the serving, and then processing it in the compute node too. It computes all of these things, as I mentioned, the filtering, all of these aggregation in that layer. And then there's also metadata management layer, in which is managing all of these, the cluster, all of these things too on that layer. And then there's also a storage layer as well, that it kind of stores up all the data in the meta store over here on the right side in there. So, all right, so example of rising wave use cases, just to give you an idea. Basically, you can use it as streaming, like ETL, kind of extract, transform, load, if you're familiar with that, right? And so you can kind of have moving data going through different systems in real time as they come in. You do this kind of streaming, kind of real time kind of ETL. And then there's also analytics too. You can practice like analyzing data as it is generated or received rather than after the fact. So it's everything very fast and dynamic too. Also too, as such, it enables like continuous event ingestion and processing. And it can also detect like patterns as the data happens. It will be performing those things and setting up like correlations, within a stream of events too. So pretty dynamic, essentially. And also too, now we're an AI meetup, so that's what I want to bring to your attention, is that they are also essentially ready for you to also use it as part of your solution to build out like Gen AI type of applications, ChatGPT. Basically, it forms part of a RAG kind of data pipeline and gives you like fresh and real-time data. So, okay, so here too, oops. Oh, actually, I don't know why. Okay, here we go. So there's just also an example that just wanted to point out to you too. I'll be sharing these slides too. Basically, they have an example of essentially too, you can use like, you have Twitter and you want to identify certain like tags, maybe, some data. You can actually use their rising wave and then use completely like SQL kind of processing to set up and then capture maybe certain tags of the day and doing all the aggregation too. So that's an example. But again, I don't have time to kind of step through it, but you can also look to it. It's already in their example too, in the slide there. And essentially, it guides you. This is pretty good. The example guides you, and it has a Docker image that you can basically Docker compose up and then bring it up. And it's already kind of built in all of the Kafka topics, all of these things, and it simulates a Twitter feed, feeding into your pipeline like that. And then over here too, you can then connect rising wave to the data streams too. And then basically, all of these things here, you can, this particular thing is just showing you can capture certain data that you are interested in, some certain tags, and you can kind of essentially extract from the text field over here, for example, over there. And then basically they have this feature called materialized view, and it basically tracks how often maybe each hashtag that you are interested in, right? And you can kind of aggregate how many times the hashtag is being used or being, essentially occurs, in your Twitter. Then you can count them. You can do all the aggregation too. So this is what it is. And basically then after that, you can then use it to query your results as well. So that's just a quick example. Okay, over here, let me also quickly to kind of talk about RAG data pipeline. Very often too, you also want to involve the use of a vector database. As such, really quickly, is that vector database essentially is a purpose-built database that serves up vector data type. And I actually did a talk last time, I think with AICAMP, or maybe back in November or December, about vector database. Why is it important for ChatGPT? It's because, as you know, ChatGPT, we're kind of looking at data, and you have to do a lot of querying. And in order to be able to support multi-dimensional data in a ChatGPT type of application, then we're using vector data type to kind of do it, because essentially we're looking at data no longer a single dimension scalar type of data type. We're talking about multi-dimension, because data is represented as vector that has like some measurement plus the direction, the magnitude of it, right? So if you're a math person, you probably can understand this. It makes heavy use of linear algebra to do like vector linear algebra type of searches, like cosine, similarities, and Euclidean distance, all of these things too. So just kind of like really quickly kind of explain to you. And plus too, in order to be able to process your data, you do need to convert your data to what is called embeddings. So you're like representing data, right? A string of text has to be first broken up into different words, and each word have to be converted to essentially floating point numbers. And then if you look into a vector database, a column of vector data type is just essentially, an array of floating point numbers in there. So it's just if you kind of do a query of your vector data type, you would just see strings of floating point numbers in different arrays like that. So as such, it also depends too, like the embedding too is also very much depend on the kind of model that you use it to, like specification. So very typical too, we're using OpenAI. I think there's I forgot the name, I think embedding like ADA2 or something. Usually you use that, but make sure that when you convert your data, you use the same model as you do for when you use it for querying your string that comes into. So that's important. Okay, so it's essentially real quickly kind of explain, vector embeddings can be used for vector search, clustering, recommendations, anomaly detection, diversity measurement, and classification. So these are like essentially the highlighting the use. Here I won't kind of spend way too much time, but essentially I talk about vector. If you kind of look at it being represented in a two-dimensional graph, vector data, it can be, how it looks like in a graph. So when you do matches, this probably will give you a better idea. If I have a cat or a dog, they are being represented as such, like over here an example, a cat and a dog, and then a house is a little further away because maybe you are searching for a cat, you want to look for something that's most similar would be a dog because it's kind of animal. Then you can see too by distancing, they are closer to each other like that. So, okay, so why am I bringing this up is because that's important too, and then very often too, essentially when you build data pipeline too, you also wanted to make sure you're taking in query, your query, you need to convert it to embeddings and essentially, kind of look into what's being stored and then you're performing like similarity kind of searches too. Okay, so also too, like wanting to then going back right outside of the vector database, when we talk about typical data pipeline that brings data to the vector database, these are usually the steps, is that you need to read data from a source, such as like an S3 bucket or a website, a Kafka topic or something. A Kafka topic could be gathering feeds from a Twitter kind of continuous feed into it. You read the data from the source, then you have to process the data to extract the text in order to vectorize it. And then you split the text into chunks of a given size, and then compute the vector embeddings for each chunk, and then write the chunks to the vector database, and then you clean up the obsolete data from the vector database. So just want to kind of like bring to your attention, these are kind of the usual steps. So here it is, just a really quick example of experimenting with a ChatGPT data pipeline using rising wave and PG factor. For example, over here, I talk about using a Twitter feed. We'll be building, actually, this talk is myself and also a rising wave consultant who is doing that, and we kind of work on it, and we kind of still working on this example. So anyway, so we have a Twitter feed that basically, feed data, and then using rising wave, that basically will sort through the feed and find the text that you're looking for. And then from the text, we can then use it to construct a prompt accordingly too. So prompt, you can be using like LangChain or Llama Index 2 or something to construct a prompt, for example. And then from there, then you can send it over to a chatbot that, for example, is built with a vector database too. So that's the idea of this RAG data flow in here. As we all know, LLMs are they are big, contain a lot of data, but they are also very static, right, in their data that's missing. So you always want to use a RAG type of approach to supplement what you're missing in the LLM to kind of supply additional data to it. So that's kind of a suggestion of this flow. And basically, this kind of explain a little bit more to how rising wave can fit in here. So we're talking about, the left side is large language models that are being trained. And essentially, too, in the inference phase, that's what you're doing, right? You're using rising wave to find some text and construct the prompt. And then essentially, too, from the prompt, you send it to the LLM for chat completion. And that's how you can kind of look for some answers that you need like that. Okay, so these are just also examples of interactions between the different components in a RAG type of scenario. You can look at like a RAG application, and then in the middle there is more with the database, the ingestion and embedding, and essentially application would send the text for processing. It goes over, and OpenAI is the one that you are relying on for some embedding specification, and essentially from there it returns processed text too. So you can see between application And the database ingestion embeddings, it will store the process text over to the database, and it confirms its storage, and then you can then use it to query the stored text, and then that will return you the query results. So these are just kind of high level, kind of state diagram explaining how they interact too. All right, so this one is just, again, another example of a RAG application in a diagram form too, as you can see. But I won't kind of go into all the detail now. But okay, so I think I kind of talked for about 20 minutes plus a bit of time wasted. So I just don't want to keep it way too long, but just give you an idea. You can think of, if you're considering building a RAG data type and needing like a quick database, you can consider using Rising Wave. It's open source and everything. So, and also, first of all, let me share the slide deck if you're interested in it. This is the slide deck, and I will also share it on the Slack, the AICamp Slack too, in case you don't get it now. And here too, with Rising Wave, this is the documentation for Rising Wave if you're interested to find out more about using it to build your RAG data pipeline. And also, I have a Twitch stream too. So I usually, these days, I start talking too about kind of Gen AI, ChatGPT, using LangChain. I myself too am learning some of these because I'm mostly a Java person. But here I am also learning Python, and it's just typical. I mean, the de facto language for for machine learning AI things. So.
Are you in Chicago or are you on the West Coast?
I'm in Chicago, so I'm local here too. So I'm always available too. So here are my contact information, my LinkedIn, and then my Twitter or X feed. Also, I have a Discord channel too if you like to stay in touch. Yeah. So I invite you, to feel free to reach out anytime too. So thank you very much. Yes. Okay, thank you. Yeah. Okay, cool. I'm not sure if folks would have questions, and yes, yeah.
So two questions related. One, when you say real-time analytics, thanks for the mics. When you say real-time analytics, does it mean in database computing? And somewhat related, with a vector database, don't you have stability issues? In other words, it's all dependent on the basis, and the small change in the basis can lead to a large change in the coefficient.
I think you are asking many questions in that statement. Well, the thing is, in this particular case, I was kind of citing example of using Rising Wave. It is best to be used as, use that tool for analytics type of purposes. So as such too, it is a tool that enables you to do real time as data comes in. It does ingestion and then do all the processing, the stream. Like I talk about the filtering, the aggregation, the windowing, all of these things you can do it too. It's kind of, think of data is constantly moving, and it can capture it right away and also perform the analysis for you in real time. And that's what it is. Am I answering your questions? Because it sounds like your question is quite, it contains more than just one question in your question. So yeah.
Right. So the question was kind of to clarify. You could potentially build something into the database as an external app, and then just pull the data continuously, feed it into that app.
Yeah.
When I say in database computing, it means you're doing the analysis. You have the tools right there in the database.
Oh, in the database. Yes, I think you can think of it like that because they allow you to build like what is called like materialized views, and that's kind of in the database too. Yes, yeah. So in that sense, yeah, it is. That's what it is. The materialized views is within the database. Yes, yeah. So it'll be also
similar to Flink sort of thing.
Yes, and exactly. Apache Flink. Yes, it's kind of similar to that. Yeah, that's right. Yeah, that's right. Yeah.
Just a quick question, general softball question.
Sure.
You guys are in the right town for this because we have commodity exchanges here.
Oh yes, commodity.
So are you guys using any of the trading houses, any of the data centers for trading?
What trading data? No, not at this time. But I should talk with you because it will be interesting too to see how it can be applied, right, in a trading kind of place, right? Yeah, that's right. Yeah, I didn't even think of. Yeah, that's a good thing. Yeah, as such, I mean, these are very new, so they are also. I mean, the company is a startup company. There's also experimenting too. Like the number of use cases can be, boundless, right? You can think of new ways of utilizing it. I think we're encouraging everybody to try that too.
I can see where you guys would have your Rising Wave box commodity, Globex, the Chicago
Globex, yeah,
Mercantile
Mercantile.
Exchange Data Center,
Yeah.
their own data center.
Yeah.
You guys release it to the general trading community.
Yeah, true, true. Yeah. Okay, that's great. Yeah, let me talk with you some more. I'm sure if I tell the Rising Wave people, they will be happy. Yeah, very young company too. So yeah, few people. So yeah, thank you. Yes.
As a student, if we want to use the Rising Wave in our project,
Yeah.
so what should we do?
Oh yeah, sure.
Is there any specific
Aside you can actually, you can kind of run it local, so to speak, like build your Docker image and all of these things. And you can take a look into that doc too. Otherwise, they also have a managed cloud platform as well. Yeah, that one I didn't get into it. Even I'm also trying to get into it. And right now, you can use it for 7 days, like a free trial too. Yeah, but if you're interested, connect with me. If you're interested with their stuff, I can connect with you, with the Rising Wave folks. Yeah, they can extend it for you too if you need more time for your experiment. So thank you. Yeah.
Open source.
It's open source too. Yeah. So this is, you can also get it too.
The
Yeah.
hosted version probably costs something.
Yeah, that's right. If you want more than just the 7-day trial. Yeah, but they allow you to use longer than that if you need to. So that's a nice thing. So yeah. Okay. Yeah. All right. Well, thank you. Yeah, I'm around too. So if you need more information, feel free to come by. So yeah, and then I'll hand the stage over to David next. Yeah. Okay. Thank you. Thank you.
Hello? 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 Hello?
Hello, hello. Yeah. Oh, is it blinking? Oh, there's another one. Yeah. Yeah.
Hello? Hello?
Yeah.
Oh, you won't.
Yeah,
Okay.
you will not. It's directly going there.
Gotcha.
Yeah. It's just for recording. That's what the.
Oh, okay.
That's what
Gotcha.
For the room. Yeah.
Okay. This is for the recording. The other one's for the room.
To the system, so that's the problem.
Okay, beautiful. All right, thank you. Okay, hello everyone. First, I had a couple questions. Who is familiar with WatsonX? Yeah. Oh. Oh, okay. Yeah, hi everyone. Who is familiar with WatsonX? Extreme users out there?
I was part of Watson Build 2018, 2019. So
Oh, nice. Okay. Well, well, welcome. And you're in for a very nice presentation. Actually, the two presentations that went before, Dean's and Ferris's, 100% complement what I'm about to show you here, because what we are the end users of their applications. And it is a fascinating journey. Okay, so let's, and I call this the art of the possible. Oh no, we're good. I'm going to be flipping between software and this. Okay, and let me grab this guy. Okay, I am a member of the Build Lab team. My name is David Baccarella. And just to give you a little idea of what we do on a daily basis is we meet with partners. We take their use cases that they're trying to solve with generative AI and solution or create a technical solution and co-create with them so they learn the technology and become self-sufficient with it, really to take their products to the next level. And what I associate this with is if you remember the old-fashioned games, the little characters would get a power pill and their character would get a little bit bigger. So that's exactly what we're trying to do, empower our partners. And we also go as far as to the to more of the business end with a go-to-market plan. And so when I started with generative AI, it came out in July of last year. And I have to admit, I wasn't really impressed with it, and I wasn't impressed with GTP for different reasons. But since then, I've become a complete believer in AI because of the technical experiences I've had in the last 7 months. I wouldn't look at any other technologies at the moment. So first, I'm going to give you a little bit of information about WatsonX itself. The platform consists of 3 parts. We call it WatsonX.data, WatsonX.ai, and WatsonX.governance. And WatsonX.data, I'm not going to talk to too much. It's kind of data-y. Gives you the ability, actually what we call a lake house, which gives you the freedom to store data in various formats and an easy way to get to that data. And also configure it to work with WatsonX AI and the governance. WatsonX AI, of course, what we'll be spending a majority of our time talking about, but the governance is very important. The governance is what gives us kind of an edge on the market, definitely an edge, because we are able to monitor what the AI is doing, tell you where or what documents are being referenced based on like a Q&A with an AI tool. And we also monitor things, like Ferris mentioned, in terms of drift. So we monitor drift, set off alarms, say, hey, time to reset this thing back to the way you had it, or do additional training to bring it up to par. And so that is the one distinguishing factor between IBM and our competition. Our competition is now building this stuff, so they're catching up. And but right now, might be a real good thing to take a look at. Okay, and in terms of governance, we have a little a piece of information with regards to the companies that we're speaking to, and to show you the importance that explainability of your results are of concern to 48% of the people we question. Ethics, 42%. Concerns about bias of a model is 46%, and trust, overall trustworthiness, 42%. So business leaders need to have these concerns addressed, for that adoption to occur, and that's in part what our governance brings. Okay, the other thing I wanted to note about WatsonX is that we run on Red Hat. And we are deployable to any cloud. So we are completely cloud agnostic. With CPD and the appropriate modules, we can be running WatsonX with AI, very, very quickly on any of those environments. So we're not particularly partial to particular kinds of clouds. Okay, now for some AI. I don't think I'm going to get to the level that the other gentleman got into here, but essentially what I wanted to say with regards to WatsonX AI is that we start with the foundation model. From it, we create an LLM, and the LLM has the ability for us to execute NLP actions on it, such as classification, summarization, sentiment analysis, question answering, etc. And essentially, the way these models appear to work is that they heavily rely upon memory. and the ability to search through those memories to find the most probabilistic response to a question. So if we were to ask an AI, no use crying over spilt what, most likely it would come back with milk, because that is probably found in a lot of literature, and these models are trained with terabytes of information. And also IBM is going beyond just the large language model domain into chemistry, earth science, vision, and other models that will be coming out. Oh, one other thing to mention about models is that as of second quarter, we're shooting for bring your own AI. So expect that to be coming, where we can really start leveraging tools that specialize in like PII. And in fact, I'm going to be coming back to PII a little bit later, which is a very interesting use case for the software. Okay, and one of the tools I want to highlight here, and we're actually going to be seeing this in real time momentarily, is our prompt lab. It's an interactive prompt builder. So when you get into our tools, you could just type and start experimenting with the models. Not only that, but you can set the hyperparameters that you're using with the models to get different results and really perfect that interaction with the artificial intelligence. And let's see here. Yeah, one thing I wanted to note with regards to working with the models is that there are two key settings within our tools called greedy and sampling. Greedy is best for deterministic behavior, has very few hyperparameters, and but when you use the sampling, what it gives you is the ability to flavor the language. So by playing with the temperature, top K, top P, random seed, you start to see some flavor in language. And so for instance, if I were to use greedy, I might see, don't cry over spilt milk versus don't weep when the moo juice is spilled. And that sort of gives an indication as to the flavor that words can be interpreted by these models. Okay, let's see here. Okay, beautiful. Now I'm going to take you guys over to the system itself. Okay, what we're currently looking at is our live system. And there's a couple things I want to illustrate. In this particular application, what I'm doing is translating the input to English. And so I simply click this button. And what this the Spanish sentence that should actually be mi teléfono funcione muy bien. My phone works well. And you can see we have some inputs here to actually do some of the training. And it looks like I have German, French, and Spanish here. And we actually provided the English translation to clue in the AI that we're looking to do exactly translation. But the prompt is the interesting thing. It is so simple, and that's a very important point. Translate the input to English is all I needed to do when interacting with the model, which really speaks to the increase in productivity that you would have as opposed to trying to do this in a different way. Okay, there's a couple things I want to indicate here. Number one is code. If you need to execute this AI code, you simply press this button and you have it in curl. You have Node.js and Python. Just very nice. And also, these are the model parameters I was speaking about earlier, so that you could work with them as you're experimenting with your prompt. And finally, I was interested in showing you how to save something. Here it is. I'm going to click Save As. And in this case, I could either save the prompt template, which is exactly what we're looking at. I'm not really sure what the session does, but the notebook is as its name implies. I can create a Python notebook, import it to my other tools, and be off to the races. Okay, one other quick demo I'll show you here is what language is being spoken. Okay, so again, if you notice that the statement is very straightforward, what source language was used in the input statement? And here I have French, où est le restaurant? And we hit generate. And we see we have French. Now this all comes in really handy in just a moment, because now I'm going to hopefully illuminate you to the other tools IBM has, which absolutely complements what we're doing here in the AI. And I'm going to put this down for momentarily. Okay, this isn't the first time you've heard the word or term RAG, Retrieval Augmented Generative AI, today. And this here is actually an architecture diagram depicting this particular feature, I guess, methodology. I think methodology is a better word. And this is in part to deal with controlling what information a generative AI delivers to the end user. We're not very fond of the idea of using or seeing that training data come up, because you just never know what you're going to get. And so we worked on several different types of generative AI, and this is just one implementation. And if we see here, we have this, one thing that really distinguishes it, we're picking the data that we're letting the AI act upon and storing it in a tool we have called Discovery. Now, interestingly, what we discovered is that when we ask questions of our Discovery is really a file retrieval system, and that file retrieval brings back passages. And these passages are simply like cut and paste type information, so they're not really, they're nice for maybe a technician, but not so nice for your regular person or like somebody who's like trying to book an airline ticket. They would appreciate more conventional speech. So what we do is we search for these answers, and we pull the top 10, form that into an article, push that off to AI, and say, give me an answer, feeding it the same question. It goes through those documents of authorized information and comes back with a really clean, crisp answer, for the end users. And then we're able to deliver that back to them. And the other interesting component here is our Watson Assistant. It's a chatbot that's fully integrated with Discovery, with WatsonX AI, and delivers the end product very, very quickly. So I'm just absolutely stunned. And let's move on. Okay, now to this end, one of the most interesting implementation is what I call the Universal Translator. That actually uses RAG as part of the offering. And the interesting things here are how the Watson Assistant processes this message, which also ties back to your PII from Ferris. When a text message comes in to Watson Assistant and it's intercepted through the pre-message processor, that message is processed before the Watson core application receives it, which means that if we do anything to the message at that time, Watson will never know, hence its logs will never know. And so it's a perfect spot for PII detection and elimination, and I'll actually be showing that to you momentarily. And on the flip side, we have the post message processing, which gives us the last chance to alter a message prior to a user actually getting it out of Watson Assistant, again, to protect PII. And yeah, it's quite amazing. And the other real interesting thing here is that through this pre and post message processing, we still have access to our session variables within Watson. So when you get a message coming in, I can say, what language is that person speaking? Say, oh, you're speaking Spanish? Okay, store that in Watson Assistant. So then when I produce my output, my post can go back and say, what's that variable set to? Translate that language to the preferred language, which in this case, would be Spanish. Now, in between, okay, we converted our initial Spanish to English. We converted our English to Spanish in the output, but we were able to process Q&A through discovery, perfecting the solution with Watson, with WatsonX, LLM model, and deliver that all in English. So we maintained the entire site, Q&A, document loading, everything in one single language, and just on the peripheries, made the change to language, which kept the solution extremely simple, and effective. The only limitation that we have currently on the actual language translation is the models, or the limitations that the models put on us. And I believe next quarter IBM is coming out with an official model specifically built for translation. And although the current models that are available are extremely effective, but I can hardly wait till they get a lot of the Eastern languages like Telugu and Japanese and others. But they're on the way. Okay, and I believe I've covered that. Okay, so now I'm going to actually show you this in operation. Boy, I really went off script there. Okay. Okay, what you're looking at now is actually a Watson Assistant instance. It's up on a web page. And I've specifically built, for this demonstration, a pre-webhook that detects the word smog and considers that like a dirty word or a personal information. And what it does is it finds it replaces that word with 4 asterisks. Then WatsonX processes the message like normally. And then when it processes or sends that message out to the post, it converts the 4 stars once it's detected into the word fresh air. So let's see that work here. Okay, so I'm typing in I like smog. And Watson responds with I like fresh air. So let's actually see what that code looks like. Now within the IBM Cloud, we have something called Code Engine, which provides a really convenient way of writing applications and deploying them on cloud so that they're immediately available. And you'll be seeing a little bit about that in the context of the code I'm showing you here. There's function 59. And oh, the other really fascinating thing about Watson Assistant is that when it does the process of handling the request, there's actually a router in front of it that actually redirects the request to a specialized function that handles it. In this case, we actually define what that function is. In this case, it's this, I think it's called function 59. And we trap the request object. So the request comes from the end user, gets trapped here. We modify that request object, and then just return it back to Watson Assistant. And so Watson Assistant is completely oblivious to our interception of that request object, and we have the ability to manipulate any part of the request object we want. In this particular case, I picked up on the text, as you can see here, payload input text. And I tell it, if you find the word smog, replace it with 4 asterisks. And, store it back in the object. And send the object, straight through to Watson Assistant. And on the reverse side, we do just the opposite. This is a little bit different because what we notice here in the output, aside from the field names, we see an array. And that array is actually significant because Watson has the ability to produce lists that come back to the end user. And when that occurs, it just keeps each of the messages on separate lines. So if you were doing something like translation, you'd have to march through them. But the ability is right there. And we see here is where we do the replacement in the object just before it goes to the end user. And hence, when I say I like smog, Watson responds with I like fresh air. And we have the ability to reach out to do the translation from the prompt lab that we were looking at. And that really excited me about this technology. And there's probably another 5 or 6 use cases, which I'm not going to articulate today, that were absolutely astounding. And yeah, I really hope you guys have some fun with this. And if you want some help on putting things together, just reach out to me. Okay, thanks. Yeah, questions?
Thank you. I know this is kind of probably a flippant remark, but and I realize that there's more to it than meets the eye. But what you showed us looks like a regular expression.
A regular what?
Expression. Search and replace.
Yes, it is.
Technology has been known for quite some time.
Yes. Yeah, and in that place is where we can actually do more sophisticated things like making calls out to, to our artificial intelligence, to the APIs, and execute code. Yes. The idea there is that it's everything that you need to put this together is there. They're like the building blocks for greater structures. Yeah.
Hi. So what foundation models did you use?
Okay, foundation models? Yeah, we take a look at
Showing the RAG application.
Okay, these are the models that are currently available to us, and coming second quarter of this year, we will be able to let a user bring their own model and leverage it.
So why did you guys pick these particular ones?
They went through a vetting process within IBM, and a couple of them are ours, like Granite. 13B Chat is actually produced by IBM. So it is actually like a competitor to GTP and other models.
And would you be able to speak about, as far as the infrastructure goes, like how many GPUs each model is hosted upon, and how do you do scaling for it?
Oh yeah, yeah, absolutely. With regards to like deployment, in fact, we just did one recently where we implemented WatsonX AI, Watson Assistant, and Discovery, just basically the things I showed you, at a client site. And what we had learned in the process is that certain models take more GPUs than others, and they required the use of 3 models. All those models that we're seeing here in this list require 1 GPU, except for one of them. Well, granted, it actually takes more too, but the main one was Llama. Llama's the 70B that they wanted to use that took 4 GPUs. And so we ended up designing was a system with 8 GPUs available, and we also set it up in 2 zones within the cloud to give it the high availability. So if one zone went down, the other one would take over. But that also gives us actually twice the amount of GPU that is required. And so that's a little bit about the infrastructure. Yes?
I can answer that more specifically, actually. I worked on the Watson before the Alliance. It turns out those 17 billion parameter models fit in an A100. I think they might fit in a 40 gigabyte memory GPU, but I think they actually take the 80, which is the top of the line. Whereas the 70B, like you said, those do require more than 1 GPU. So a 13 billion model at floating point 32 is going to be roughly an A100, more or less.
Yeah, we need A100s or H100s. Yeah. Yeah, they're expensive.
So that is a problem. Yeah, the question was, do you have to scale it as more come in? Yeah, there is I don't remember the numbers, but yeah, you quickly start finding you need to parallelize the invocations across multiple instances.
Yeah, and that actually makes the use of small models even more attractive. So if you can use a small model as opposed to something big, that means you have more GPUs and more capabilities, but specialized capabilities.
Last comment I'll make, there was Mixtral up there, which is a mixture of experts model, and that seems to be the hot thing in the next year for high performance but relatively low inference overhead. Yeah, that one, it's Mixtral.
Mm-hmm. Yeah, very nice. Yeah, any other questions? Okay, I think we're good to go. All right, thank you.